All right, so in this video we're going to talk about profit and marginal profit. So we'll start with the definition. So profit is revenue minus costs. Or P equals R minus C. Marginal profit is the derivative of profit, and it's denoted MP with a bar over it. And marginal profit is marginal revenue minus marginal costs. All right, let's look at an example. So say a company produces widgets for $4 per widget, and production startup costs are $40,000. Let's say the demand or price curve for widgets is linear, and furthermore, when the price is $15, the company can sell 5,000 widgets, and when the price is $10, they can sell 8,000 widgets. Find the profit, marginal profit, and estimate the profit from producing and selling the 601st widget. Okay, so in this problem we're going to first construct the revenue and cost functions. So to construct the revenue function, we need to first construct the price, because revenue, which is R, is price times X. So let's do the price analysis here. So we have the price when we sell 5,000 units is 15. And the price when we sell 8,000 units, it's like right here, is 10. Here's our price curve. And we're going to use the point slope form of a line to figure out this price curve. So we'll use the point 5,015. So when the price is 15, X is 5,000. And the slope is -5. It goes down 5 when we go over 3,000. So -5 over 3,000. So working this out, we'll get P minus 15 equals -1 over 600 times X minus 5,000. So P equals -1 over 600 X plus 5,000 over 600 plus 15. And that's going to work out to be -1 over 600 plus, what is this, 25 over 3 plus 45 over 3, which is -1 over 600x plus 70 over 3. So there's our price function. And then our revenue function, r of x is going to be price, negative 1 over 600x plus 70 over 3 times x, or negative 1 over 600x squared plus 70 over 3x. Okay, so now let's construct our cost function. So our cost function comes from the $4 a widget and the 40,000 startup costs. So let's write it up here. Cost is C, which is 40,000 plus 4x. So we have our cost, we have our revenue, so now we can write our profit. Our profit, which we'll call P of x, is revenue minus cost, or negative 1 over 600x squared plus 70 over 3x minus 40,000 plus 4x. Okay, if we simplify this, we'll get negative 1 over 600x squared, 70 over 3 minus 4 is 58, right? So 4 is 12 over 3, and 70 minus 12 is 58. So we'll have 58 over 3x minus 40,000. Okay, then our marginal profit is going to be the derivative of our profit function, so negative 1 over 600, 2x plus 58 over 3, which we can simplify as negative 1 over 300x plus 58 over 3. All right, so now I want to take a step back and just draw our profit curve. So our profit curve is this quadratic. So I want to sketch this quadratic for you. So I'm going to make this axis 20K, 40K, 60K, 80K, 100K. And this axis will be 5K, 10K, and 15K. Okay, so this is the profit function, and the marginal profit gives us the slope of this profit function. We're looking at the value 600, and the reason we're using 600 and not 601 is we want to use the slope at 600 to predict the profit from the 601st unit. So the marginal profit, we're going to now put 600 into it. So here's 600, and we're using that slope to estimate the profit from the 601st item. We'll put 600 into this, so we'll get 1 over 300 times 600 plus 58 over 3. That gives us negative 2 plus 58 over 3. So negative 6 plus 58 over 3, which is 52 over 3, which is approximately 17 and 0.33 if we round. Let's make this a little squiggly equal sign here. So the marginal profit is approximately $17.33. All right, I hope you found this video useful.